Okay, so when we talk about symmetry, there are three different types. So when we talk about x-axis symmetry, what that means is that if you take the graph and fold it along the x-axis, it's going to have symmetry with the x-axis. So the portion above the x-axis and the portion below the x-axis is a match. That's x-axis symmetry. Y-axis symmetry it looks something like this. So do you see how with the y-axis, if you could imagine that you were taking the y-axis and folding it, the left side of the y-axis and the right side of the y-axis will match up. And then origin symmetry the easiest one to think of is a circle that's centered at the origin. Because if you fold it along the x-axis, it's going to match up. And if you fold it along the y-axis, it's still going to match up. So those are your three different types of symmetry. We're going to check it algebraically. So to find the x-axis symmetry, we're going to do the opposite. So if I'm looking for x-axis symmetry, I'm going to replace y with negative y. If I'm looking for y-axis symmetry, I'm going to replace x with negative x. For origin symmetry, I'm going to replace both. So the easy way to do this, though, is if you answer yes for both of these, if it has x and y symmetry, that means that it automatically has origin symmetry. So that's kind of an easy way to do the symmetry test. So we don't necessarily even need to do this third test. So if we get a yes and a yes, it's going to be a yes here. If one of these is a no, it's an automatic no for origin. All right, so let's go ahead and copy down these three, and we're going to do our symmetry test. So for x-axis symmetry, I'm going to replace y with negative y. So we have y squared equals x plus 4. And then I'm going to put a negative y in here. So what is negative y squared? Positive or negative?
Positive.
Positive. So when you square a negative, it flips back to positive. So even though I put in a negative, my answer, my simplified answer is a match to what I started off with originally. So after you replace the y with negative y, it simplifies to be exactly the equation we started off with, which means that this graph would have x-axis symmetry.
Well, when you did negative y squared, wouldn't that cancel out with 2 squared, like the squared?
No. So negative 1 squared is positive 1, and y squared is y. The only way to cancel out a square is to take the square root, because that's the opposite of a square. So again, only because these two match, this equation matches this equation, that's why it's yes. So I already know the answer is no, but I want you to see why it's a no. So let's go ahead and check for y-axis symmetry. So if I'm checking for y-axis symmetry, I would replace y. No, not y. I am going to replace x with negative x. So that's y squared equals, and then we have negative x plus 4. Notice that in this example, we don't have an exponent on this x to flip that sign back to positive. So this is going to stay negative, which means it simplifies down to y squared equals negative x plus 4. Is that a match to the original equation? No. So that means that this does not have y-axis symmetry. And because it doesn't have x and y axis symmetry, I automatically know that it doesn't have origin symmetry. So I don't even need to do the test. For origin, it's going to be no. So the only way it has symmetry is if after you simplify it, if it's a match to the original. So this first one has x-axis symmetry only. All right, so let's check the second equation. Go ahead and copy it down if you haven't already. So for x-axis, if I replace the y with negative y, does this simplify? Is there something happening to the y to make that go back positive? And the only way it would do that is if it had an even exponent. So this is going to be a no, because this is the simplified equation. So for x-axis, it is no. Now let's check for y-axis. So for y-axis, I have y equals, then I'm going to put a negative x here. So if I take that and raise it to the power of 4, is that going to make that x positive again, or will it stay negative? It's going to make it positive. Anytime your exponent is even, it's going to switch back to positive. So x squared makes it positive, x to the 4th makes it positive, x to the 6th, x to the 8th, x to the 10th. So this is actually going to simplify back to a positive x, which gives us y equals positive x to the 4th minus 1, which is a match to the original equation. So this does have y-axis symmetry. So this is a yes. And what about origin? What do you think? Is that going to be a yes or a no? It's a no. We don't even need to test it. It's going to be a no. All right. So now let's go ahead and look at question 3. So for x-axis, I have negative y equals the 5th root of x. And that's going to be a no because nothing is happening to that y to switch it back to positive. So that's a no. So we've already knocked out x-axis and we've already knocked out origin. So the only thing we have left to check for is the y-axis. So y equals the 5th root of negative x. So what you're doing is you're going to take the 5th root of negative 1. The 5th root of negative 1 is negative 1. So what this simplifies down to is y equals negative 5th root of x. So even though the x switches back to positive, because I'm taking the 5th root of negative 1, the 5th root of negative 1 is negative 1. But regardless, that is not a match to my original equation. So this is a no. So my origin is also going to be no. Odd exponents, because that's still x to the 1/5, and 1/5 is an odd exponent. So we only have 2 more equations to test, and then that's it. We made it to the end of all of our material. All right, go ahead and copy down 4 and 5. So would you say yes or no for x-axis? Nope. So again, remember, odd exponents stay negative, and both of these x's in this equation have powers that are odd. So because they're odd, it's not going to switch back to positive. So this is actually going to simplify down to y equals negative 3x cubed minus 2x, which is not a match, so that is a no. And because they're both no, we automatically know that origin is also a no. So there is no symmetry in this graph. And you probably recognize that number 5 is an equation for a circle that has a center at the origin with a radius of 4. So this is the only one that will have origin symmetry. So let's go ahead and test it out. And I recognize that without doing it because both x and y have an even power. So that's how I can tell immediately before I even do any algebraic tests. So when I do x-axis, that'll be x squared plus, and then negative y goes here. Because I'm squaring the negative y, it flips back to positive. So that is a yes. Because that negative y is squared, which makes it positive. When we do y-axis symmetry, we're putting our negative where x is. And because x is also squared, that is going to flip back to positive. And because I got 2 yeses, origin will also be yes.